Heyo, it's Mr. Otwell, the Math Master, helping you master math. In this video, we'll be solving systems of equations with 3 variables. Those are the ones where you have 3 different equations with 3 different variables, and you have to find every single variable that make all of those true. At first, it seems kind of intimidating, but we're gonna take this really big concept and break it down into something more manageable so that you can walk into these kinds of equations feeling confident and ready to go. If you're new to this channel, I make math tutorial videos as well as teacher tip videos, so please like and subscribe to support our community and help it grow. Let's do this. All right, so let's go. We've got a system of equations. This one looks a little scarier because there's 3 equations and 3 variables, and we gotta find what x, y, and z value makes all 3 true. So at first you may look at this and be like, I have no idea what to do. So really what our goal is gonna be is take that system of 3 equations and 3 variables and turn it into a system with 2 equations and 2 variables. Because up until this point, you should be well equipped to deal with those. So let's just turn it into something that's more familiar. Honestly, this looks really intimidating with all these different steps and stuff, but really I'm gonna walk you through it all and it won't be so bad. So the first step is just to make sure everything is in standard form. You want your x, your y, your z, and you want your constant on the right side. So we already have that. In the notes, I just mentioned like the a, b, c, and d in standard form. They're just numbers, they're real numbers. So don't let this kind of freak you out. You just want your x's with your x's, your y's with your y's, and your z's with your z's. Most of the time we get a system of equations at all, they put it in standard form for us. So this is the key here though. We want to analyze all our equations and look for a variable in all equations that has a coefficient that have common multiples. Basically what that means is you want to be thinking about where you're going. Okay, where you're going is you're going to add some equations together. It will eliminate one of the variables and then you're going to do that again. So really what you want to do is eliminate one of the variables out of all 3 of these equations. So you take a look at the coefficients of x, y, and z and see if any of these are going to set it up to where you can add some together and it'll be a little easier. So if you take a look at x, you could totally make this work. I mean, you could eliminate x by multiplying this by 2. That'll kill 1 and 3. You could do 1 and 2 then, multiply by -5, and that would work. But take a look at y. You've already got same coefficient, opposite signs. So this is pretty nice because we can just choose to eliminate y and we really don't even have to do a lot of extra multiplying. Z could work too. Basically, if you ever have a variable with a 1 or -1 as coefficient, that one's pretty manageable as well. But if you've got something like this where you've got the same coefficient for every single variable, that's what you want to choose. That's what you're doing here in step 2. You're looking at x, y, and z and trying to look at all the coefficients and figure out what will make your life the easiest when you are eliminating. Once you take a look at step 3 and 4, you want to choose some equations so that you can add them together and those variables eliminate. So what I think is the most dangerous thing about all of this is negatives. It's adding wrong. It's doing little things wrong. Because if you mess something up at the very beginning, everything else you've done just gets kind of like thrown away and it's no fun. So I want to share with you some things that I think is smart to do to really just help you stay organized. The main help I can give you there is just number your equations. I like to number them 1, 2, and 3, and I draw little circles around them, okay? So what I want to do is, as I mentioned before, eliminate y. Y is going to be the easiest variable to eliminate. So it makes sense to choose an equation that has the same coefficient, opposite sign already. So that's step 3, okay? You're going to choose 2 equations so that they have the same coefficient, opposite sign, and they'll eliminate, okay? So I'm not going to choose 1 and 2 because if I add these together right now, I'll get -10y. I can multiply by -1 and that would work. But if I take a look, I've got equation 1 and equation 3. I've already got a -5y and a +5y. So I want to choose equation 1 and equation 3. So I just go ahead and write that out. And then I just write what those equations are to the left. -x minus 5y plus z equals 17. That's equation 1 here. And then I'm going to write equation 3 right here. 2x plus 5y minus 3z equals negative 10. So we're using the elimination method here. We're going to add these equations together, so combine like terms, and that will give us a new equation. So negative x plus 2x is a positive x. Negative 5y plus 5y, those eliminate. That's what we want. This gives us 0, so that's good. And then z minus 3z is negative 2z, and then 17 minus 10 is 7. So notice, we have a new equation here, and something amazing has happened. We used to have 3 variables. Hey, now we only have 2. That's good. This is our goal, okay? This is the goal of step 3. Create a new equation that has just 2 variables. And since we made a new equation, go ahead and give that new equation a number. This is equation number 4, okay? X minus 2z equals 7. We want to do this same process and eliminate the same variable, because our goal with step 4 is to get another equation that has an x and a z in it, okay? So we go back up here. We need to choose 2 different ones. We can't choose 1 and 3 again. So if you take a look, I already talked about how you can choose 1 and 2, and that's fine. But if you take a look at 2 and 3, hey, you've already got the same coefficient opposite sign set up. You might as well choose 2 and 3, because you can just add those together. So let's rewrite it. Negative 5x minus 5y plus 5z equals 5 is equation 2. And then equation 3 is just 2x plus 5y minus 3z equals negative 10. So once again, we're using the elimination method. We're adding these equations together, so we're combining like terms. Negative 5x plus 2x is negative 3x. This is what we want. Negative 5y plus 5y gives us 0. That eliminates that variable. And then we keep going here. 5z minus 3z is 2z. And that's going to equal minus 5 when we add 5 and negative 10. So check it. Once again, we made a new equation. Let's go ahead and give that equation a new number as well. We have now, look, 1, 2, 3, 4, 5 equations. Now, this might look scary, but think about what we just did. Okay, we took a system with 3 equations and we actually just made it 2. Like, we have a bunch of information about x and z and how they relate in equation 4 and equation 5. So if we just took 4 and 5 and we wrote them together, this is what it would look like. Hey, that doesn't look too bad, right? This is a system of equations with 2 variables. This is something we're familiar with. We can just once again choose elimination. Hey, check it out. We got negative 2z and a plus 2z. It's already set up for us. So we'll be able to now add these together again to find a value for x. And that's what I'm getting at with step 5 here. You have 2 new equations with the same 2 variables. Solve the system for one of the variables. We want to solve for x because z is already set up to eliminate. So let's add these together. X minus 3x is negative 2x. These eliminate, that's good. And then we add these together and get 2. 7 minus 5 is 2. Now we just solve for x. So divide by the coefficient. What we do to one side, got to do the other. So negative 2 divided by negative 2 gives us 1. 1 times x is x. And we have x is equal to negative 1. Now you found x. It's tempting to just box your answer and go on your way, but you got to keep in mind, the solution to the system of equations is an x, a y, and a z that makes every single equation true. So really, all we found is one piece of our puzzle. We need 2 more pieces. We need an x, a y, and a z that make every single equation true. So let's think about it. We've got an x. We need to find y and z. If you think about a normal system with 2 variables, you would just plug it back into the original and solve for a variable. But check it. If we plug in x, we'll still have a y and a z. But oh, don't forget, we actually made 2 new equations that are equal. These are equivalent. Equation 4 and equation 5 are totally fair game to use. And check them out. If we substitute x into 4, we only have 1 z left in the equation. And that's good. We could then solve for z, right? So that's what our next step is. We want to do step 6 here, take the variable and substitute it into any of the other equations. 4 and 5 are already set up for us to just solve for one of the missing variables. So what I like to do is to stay organized. I found x here. I'm going to say I want to take x and substitute it into equation 4. And I like using this little notation because if we ever do make some sort of mistake with negatives or something, it's so much easier to go back and find what happened. If I've numbered everything well, if I've labeled all my steps well, it's just way easier for me. And it's way easier for your teacher, by the way, to grade. So we're going to take x, substitute it into equation 4. So here's our equation 4. So x is now going to be a -1. So we substitute -1 in for x. And then the rest of the equation is -2z equals 7. And at this point, it just becomes an equation where you just got to solve for one variable. So we want to add 1 to both sides because that will cancel this. We'll have -2z equals 8. And then we want to continue solving by dividing by the coefficient because we want to isolate z. -2 divided by -2 is 1. So we've just found that z is -4. That's pretty good, right? Because check it. We now have x and we have z. Our solution is an x, y, and a z to make all three true. So we have now 2 pieces of the puzzle. We need one more. So let's think about it, okay? We have x. We have z. We need y. We have 5 equations that we can use, okay? We've got 1, 2, 3, 4, 5. 4 and 5 aren't really useful anymore to us because we could plug in z to get x, but we already know x. So what could we do with 1, 2, or 3 in order to find y? Hey, we could just take the x and the z we have, substitute them in, and then we're just left with an equation with one variable, which is what we're trying to find, right? So that's what we're doing with step 8 here. We're taking both of these variables, x and z, and we're going to substitute those into one of the original. I always try to just make my life the easiest. These 2 equations have coefficients with x and with z. If I can just multiply less, my life will be easier. I'm just going to choose one. So I'm going to take my x and my z and substitute it into equation 1. Just as a quick reference here, I've gone ahead and rewritten equation 1 right here so that it's easy to just follow our equation and substitute in values when we get them. So this equation has negative in front of the x. So this negative is from the equation. Now we substitute x. Our x is -1. So use those parentheses when you substitute. Then follow the equation. We have -5y. We don't know y. That's what we're trying to find. Plus z. And our z is -4. So use those parentheses, substitute in -4, and finish out our equation here. Now check it. We need to make sure we're dealing with the negatives correctly, but we've got an equation with one variable, which is the one we're trying to find. So the negative of -1 gives us a +1 minus 5y. Positive and a negative gives us a negative for addition, and then equal to 17. We can combine like terms here. I like to go ahead and do that. So I have -5y minus 3 equals 17. And now we've got a nice standard little 2-step equation here. We want to add 3 to both sides. What we do to one side, gotta do the other. Bring down -5y. These cancel, and then we have 17 plus 3, that's 20. To isolate y, we want to divide by the coefficient, which is -5. If the coefficient's negative, we're dividing by a negative. What we do to one side, gotta do to the other. Then we get y is equal to -4. Now check it. Hey, we got an x, a y, and a z that make all equations true. Well, at least we hope. We can take these values, substitute them in to this system that we began with, making sure it makes every single equation true, because it's not a solution unless it works for every single equation. So I really like using Desmos here because if you use just their scientific calculator, you can tell Desmos, hey, let x equal -1, y equal -4, z equal -4. So now every time I type x or y or z, it's going to substitute that value for me. So I can just type this equation exactly as I see it, and it will substitute everything for me. When I type -x minus 5y plus z, I want to get 17. So let's see what happens. Check it out. Desmos has taken -1, -4, -4. substituted it in. We know the left side of this equation is equal to 17. The right side equals 17 as well, so we know we're good. We can go ahead and push enter and then enter in the other two equations and see what happens. So check it out. When we entered in the left side of the second equation, we got 5. Hey, the right side's 5. We know we're good. Same thing with the third equation. We got -10, -10. So we know we're right. So we know our solution is x is equal to -1, y is -4, and z is -4. Generally, when we write our solution, we write them as an ordered triple. We call it a triple because now there's 3 values instead of 2. So we get -1, -4, -4. And this is you saying my x is -1, my y is -4, and my z is also -4. So here's one example that isn't the easiest of what it can get with systems with 3 variables, but it's not the hardest either. Let's do one more just to get another example under our belt. Once again, I think it's a good idea to number our equations. I think that organization is generally the downfall of a lot of my students for these. So make sure you try to stay organized. Double check that they're in standard form, they're good. So we want to now, step 2, analyze all the equations and look for the variable that will be the easiest to eliminate. So if you take a look at x here, 3 and 6 are common multiples, so that's nice, but 5 isn't a common multiple of 3 or 6. So if we wanted to eliminate x, we're gonna have to do a lot of multiplying to make that happen. With y, oh, look at that. If you ever have a coefficient that's a 1 or a -1, you want to use that because it's really easy to turn a 1 into anything else that you need. You can turn this -1 into a -3. Real easy. You can turn this -1 into a +4. Real easy, which will allow us to eliminate those. Really, the z's work great too because we have a +1 down here. It'd be really easy to do that. And you also have a common multiple of 3 and 6. So since last time we eliminated y, just to show you it does not matter what variable we use, I'm just going to go ahead and choose z. We are going to eliminate z from our equations to create 2 new ones that just have x and y. So really a mix of any of these are going to work well. I'm just going to go ahead and use 1 and 2. So equation 1 is -3x minus y minus 3z equals -8. And equation 2 is -5x plus 3y plus 6z equals -4. So we've got our equation set up here, but remember, we're keying in on z. We want to eliminate z. So at this point, we do not have the same coefficient with opposite signs. So before we jump into this, we need to multiply this -3 by something that will get us a -6 because we want same coefficient, opposite sign. We've already got the opposite sign that we need, so we just need the same number. So remember with elimination, we cannot just multiply this term by 2. We have to multiply the entire side by 2. Remember, what we do to one side, we must do to the other side. So I'm just going to go ahead and write that right down here. We're going to take equation 1 and multiply it by 2. That's going to give us this new equation where we're going to get -6x minus 2y minus 6z equals 16. Double check your distribution. 2 times -3, -6. 2 times -1 gives us -2. 2 times -3, -6. That's what we wanted, right? And then we have a -8 times 2. Oh, snap. Check it out. This is really good that I checked my work because -8 times +2 is not +16. It's actually a -16. So I'm just even going to leave this in here because honestly, what I just did is something you need to be doing. Anytime you manipulate an equation, go back and check it. Like make sure you did the right multiplication because think about it. This is the first equation that I'm trying to use to get rid of z. Imagine if I would have just spent 5 minutes, 10 minutes solving the rest of this just to get the wrong solution and go back and check all my work and find out it happened right here. That would be terrible. So check your work as you go. So our equation of 2 times equation 1 is this new equation. We can just go ahead and write equation 2 down right here. And we want to add them together to eliminate. -6x minus 5x is -11x. Negative 2y plus 3y is just y. These eliminate, which is what we want, and this will get us a negative 20. Don't forget to check your work. Yeah, this looks good. Okay. So remember, now we have a new equation. Let's go ahead and give it a number. This can be equation 4. After that, we need to go on to step 4. We want to choose 2 other equations. So we don't want to use 1 and 2 again. We want to choose 2 other equations to make a new equation where we've eliminated z and we just have it with x and y. So I'm just going to choose 2 and 3. If you take a look up here, I need a 6 and a negative 6z so that those will eliminate. If I want to do that, I need to take equation 3 and multiply it by something that makes this coefficient a negative 6. Easy to consider when we have a coefficient of 1. That's why I like it, when there's a coefficient of 1. So since I need this to be negative 6, I'm going to multiply equation 3 by negative 6 so that I can have 6z and negative 6z. So let's just go ahead and write that. I'm going to take negative 6, multiply it by equation 3. And let's just go ahead and write it. Don't forget, you need to distribute negative 6 to every single term, okay? So the negative will flip-flop all the signs, and then the 6 will just multiply by 6. So we're going to have positive 36x plus 24y minus 6z equals positive 120. I just took negative 6 and I multiplied equation 3 by negative 6. Every single term had to be multiplied by negative 6. So now remember, we're going to add that with equation 2. So let's just go ahead and write equation 2 right below it. Negative 5x plus 3y plus 6z equals negative 4. Now, hey, we're set up. We can add these together and z will eliminate, which is what we want. So 36 minus 5, this is going to get us 31x plus 27y. These eliminate, which is what we want, and it's going to equal 116. Hey, we got another equation. Let's give it another number. Make it equation 5. Hey, check it out. Equation 4 and 5 have an x and a y. So that's a system that we know what to do with. Let's go ahead and rewrite them so that we're taking a look at both of them. They're right there. We can make a good decision about how we want to move forward. So taking a look at this system and just riding that elimination train, we've got a 1y. That's going to be really easy to work with. We want to eliminate y here. It's just going to be the easiest variable to eliminate. So we want the same coefficient, opposite sign. So we've got a 27 here. We want to multiply this term by negative 27 to flip the sign as well. So remember, what we do to one term, we've got to do it to all of them because we can't just multiply one term. So we want to multiply negative 27 by equation 4. Just to have that visual of distribution, I went ahead and wrote it for us. We need to multiply all terms by negative 27. So negative 27 times negative 11 gives us 297x. Don't be too impressed. I just used a calculator. Negative 27 times y is negative 27y equals 540. Don't let the big numbers scare you. We're doing the same process here. We're identifying a variable that we want to eliminate. We're multiplying by a number that will give us same coefficient, opposite sign. We're going to add and eliminate those. So now we have our negative 27y, which is what we want. We can go ahead and write equation 5 right below it so that we don't get too lost. Okay, we want to stay super organized. It's tempting to just try to squish everything together, but if we can just label everything, make sure we're showing our work, it's going to be much better to go back and see what we did. So let's add. This is going to give us 328x. These eliminate, and this gives us what? 656? Yeah. Oh, that makes sense, right? 656 divided by 328, that's equal to 2. So x is equal to 2. So remember, just like last time, we want to take x and substitute it into a different equation to find either y or z. Remember, you have 5 equations to choose from. 1, 2, 3 from the original, and 4 and 5 from after you eliminated a variable. Like the last one, the first 3 don't help you out because you still would have 2 variables. So you just want to choose either 4 or 5. Taking a look at 4 and 5, I would choose 4 because check it. We're about to solve for y. Y has 1 as a coefficient, just makes it easier. You could totally use 5, but then you're multiplying by bigger numbers. It's just taking you more time. You don't have to worry about that. So remember, label what you're doing. Make sure that it's clear. You're going to take your x and substitute it into equation 4. Our equation 4 is negative 11 x, which is 2, plus y equals negative 20. Now multiply, solve for y. Negative 22 plus y equals negative 20. So we want to add 22 to both sides. What we do to one side, gotta do the other. And that gives us y equals 2 as well. So we have x equals 2, y equals 2. Now we just gotta find z. So once again, we choose 1, 2, or 3. We're gonna substitute x and y to find z. I'll just use 3. We're gonna multiply by some numbers here, but z has a coefficient of 1. So that'll be nice. So just for easier reference, once again, I rewrote 3 right here so that substituting it's pretty easy. We're going to take x, we're going to take y, and we're going to substitute it into equation 3. So our equation 3 is negative 6x, which is 2, minus 4y, which is also 2, plus z equals negative 20. Negative 6 times 2 is negative 12. Negative 4 times 2 is negative 8. Plus z equals negative 20. Combine like terms here, we get negative 20 plus z equals negative 20. And last step here, add 20 to both sides so we can isolate z, and z equals 0. Now, let's check it. We want to see if 2, 2, 0 will make all of those equations at the top true. So once again, we can use Desmos. I just said let x equal 2, y equal 2, and z equal 0, which is what our solution was. I plugged in equation 1 on the left side, and I got a negative 8. So the left side equals the right, check. Plugged in the left side of equation 2, we get negative 4. The right side is negative 4, check. And plugged in the left side of equation 3, got negative 20, and hey, that's negative 20 as well. So when we substitute in 2, 2, 0, we get an x, y, z value that makes all equations true. So hopefully you found that helpful. We were able to solve a system of equations with 3 variables by turning it from 3 equations to 2, finding that variable, and working our way back. Don't forget to like and subscribe. Mr. Otwell out. Peace. Okay, go get some toys. No. Go put that back. Oh, children.